Hello and welcome to this video on the Euclidean algorithm. So the Euclidean algorithm is a computational process that computes the greatest common divisor of two positive integers. The word algorithm in general is a word that describes any sort of well-defined computational process that eventually ends and gives us a correct result. And this one's specialized to compute the GCD of two numbers. Let me show you how it works with a specific example. So we're going to use the Euclidean algorithm to find the GCD of 54 and 888. Now I know just by looking at these two numbers that the GCD has to be at least 2, because 2 is a divisor. It divides into both 54 and 888 evenly. But could it be something greater? Is there some larger number that divides them both? Well, we don't know, so that's what the algorithm is for. The algorithm is going to proceed like this. We're first going to start by taking the larger of these two numbers and dividing it by the smaller one to see what quotient and remainder we get. In other words, we're going to go over down here and set up a little long division problem. We're going to take 54 and divide this into 888 and pay attention to the quotient and the remainder we get. Now if you start doing the long division process, you're going to get something like this. And this goes in 6 times. That comes out to be 324. And the remainder here is 24. Now I'm going to go over here on the right and write this down in a slightly different format than what you see here. I'm going to encapsulate the results of this long division process like this. I'm going to write 888 is equal to 54, and I see that that went in 16 times with a remainder of 24. And you can verify that the left-hand side equals the right-hand side. And you probably remember from your grade school arithmetic that any long division process can be written out as a multiplication and addition equation like so. So that's the first step in the Euclidean algorithm. I still don't know what the GCD of those two numbers is, but I'm going to get a little bit closer if I do the next step. And that is, when you look at the results here, I have two new numbers that were created, the 54 and the 24. The 54 is not new, but the 24 is. So what I'm going to do next is switch places with the divisor and the thing I'm dividing it into. Previously, in the first step, I was using 54 as the divisor. Now I'm going to use 24 and divide it into 54 and see what I get. So what the role of 888 is now going to be played by 54, and the role of 54 is now going to be played by 24. So I'm going to create another long division problem where I take 24 into 54 and see what I get. Now this is going to be a lot easier because the numbers are smaller. 24 goes in twice, with a remainder of 6. Now I'm going to write that over here on the second line as 54 equals 24 times 2 plus 6. So again, what happened is the 54 kind of shifted over to here, and the 24 kind of shifted over to here. I still don't know what the GCD is going to be, so I'm going to do another division step where I'm going to shift the 24 to here and try to write this as another long division problem and see how many times 6 goes into 24 and what remainder I get. So I'm going to continue this process of repeated long division and shifting the divisor and the remainder over every time I do this. Now this is a much simpler problem to work out. In fact, I don't really need to write out the long division problem. I can just look and see that 24 is equal to 6 times 4 with a remainder of 0. Now, for reasons we're not going to explain here, it can be shown that this process of repeated division will eventually end with a 0 remainder. So what the Euclidean algorithm says is that once you reach a 0 remainder, you are to look up into the previous line, look up right here to the last non-zero remainder that you got, and that is the GCD. So the GCD of these two numbers, 54 and 888, is equal to 6. That's how the algorithm works. We're not going to explain the mathematical proof behind this. It might look like magic, but it does actually work for very simple reasons. And you can verify that 6 is a divisor of both of these numbers, and you can check by exhaustion that it's actually the greatest common divisor. So let's look at another example of the Euclidean algorithm. This time we're going to use some larger numbers here. We're going to find the GCD of 7 and 867,543. So what's going to happen first is we're going to take the larger of those two numbers and divide it by the smaller one. So 7 goes into 876,543. Now never fear, I've worked this out already in advance. We're not going to do the whole problem here. 125, this goes in 125,220 times, blah, 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 with a remainder of 3. So that would be written over here as a multiplication equation as 876,543 is equal to 7, there's the divisor, times 125,220, and here's the remainder of 3. Okay, so now I want to shift. I want to see if I take 7 and divide it by 3, what do I get for a quotient and what do I get for a remainder? Now notice the numbers just got dramatically smaller, and so I can answer this question here. I can fill in these two blanks here without doing any long division at all. I can just directly see that 3 will go in twice with a remainder of 1. So I haven't reached a 0 remainder yet, and the Euclidean algorithm says I need to just continue to do this process until I do have a remainder of 0. So I'm going to shift it again, and I'm going to put the 3 here, and the remainder of 1 right here, and see what the quotient and remainder turn out to be. Now this is very, very simple. This is just going to be 1 goes into 3 times, or the remainder of 0. So there's my 0 remainder, and now I'm going to look up at the last non-zero remainder, which is right here, and that's my GCD. So the GCD, greatest common divisor of 7 and 876,543, is equal to 1. Another way of saying that is that 7 and 876,543 are relatively prime. So the Euclidean algorithm works in that particular way. It's a wonderful algorithm because it tends to compute the GCD very, very quickly, and it actually doesn't involve any division at all. It just uses multiplication and addition. Thanks for watching.